So assuming that we've gone through our trick, we can ask ourselves, what would we do in a case like this? Well, the first thing is to remember we're trying to create a rectangle of size 25. And if we limit ourselves to whole numbers and we're grouping by 4 in one direction, you'll notice that we have a bit of a problem here. We can do 6, that gives us 24, but we have kind of this hanger-on out here that we're not quite sure what to do with. And so in typical math terms, we describe that as our remainder. That's what remains. After we've built the best rectangle we can, there's this remainder. And how big would the remainder be? Well, it could be 1. It could be up to 2. It could be up to 3. We wouldn't have a remainder of 4, though, because if we have 4, it would go in an additional time. This is important for us as a little bit of background information so that when I share the division by 9 problem with you, you'll know what we mean when it talks about remainder, or as the students will say later, leftovers. Basically, it is after I have built the best rectangle I can, how many do we have that just can't fit when we're dividing in terms of whole numbers. We could continue this with decimal and fraction, of course. If we were to think of it as a fraction, we would take this 1 and we would be trying to divide it into 4 equal parts. You'll notice using one of our symbols for division here, it also happens to be a symbol for fraction, isn't it? So we kind of see where we're going to be going in a few lessons from here when we talk about fraction. Fraction and division are very closely related. But for today's work, and in particular for the division by 9 problem, the takeaway that I want you to think about is when we see a symbol like the 25 divided by 4, the question that is asking us to do is to first make a rectangle, make it as good as we can, and if there's anything that's left over, then we will count that as the leftover. So this shows that it's 6, and there's our remainder of 1, because that 1 just doesn't fit. We did the best we could, but when we take our 4 and we put it into the 25, we can take care of 24 of them like this, and we can take care of 1 by just keeping track of it as a separate remainder.
In the division by 9 problem, there's some use of language here that's a little bit different that I want to make sure you understand before you get started on it. In particular, division can be thought of creating equal groups, as we found out. And sometimes we use a share with. So for example, we could describe 6 divided by 3 as 6 sharing between 3 different groups. And we ask ourselves, how large is each group? That's the language that was being used in the classroom that I'm going to be sharing with you next week. But I need you to think a little bit up front so that the discussion that this child is going to come forward with will make sense to you. A couple things about this. First, group of 4. This is just to remind you that in an ideal world, when you do mathematical problem solving, you'd like groups of 4 students. And so this particular work that we'll be talking about next week took place in a student group of 4. The second thing I want to remind you of is this notion that share with can be used to describe division. So to go back to our 24 created with broken up into 4 equal groups, we could say, what is 24 if you share it among 4 people? This particular child we'll be talking about next week discovered something, and that was that when you divide by 9, in other words, when the divisor is 9, he could determine what the remainder was. And so the statement was, I can determine the remainder of division problems in base 10 when the divisor is 9. And he had a method. You just keep adding until you cannot add any further. And so, for example, if you were dividing 63,538 by 9, what he would do is he would add each of these place values together, 6 and 3 and 5 and 4 and 8 to get 26, and then still recognize that the 2 and the 6 now can be added up to get 8. And so the remainder is 8. As it turns out, there's a way that you can check this to make sure that the remainder is correct. And that is to use your calculator and to divide. And if you see 0.88 at the end, that means that that's the remainder. What happens on our calculators is, of course, you don't have an infinite number of spaces on the calculator, and it will tell you your remainder in terms of a repeated digit. And we'll explain why that's the case when we get into decimal representations a little better. But for now, if you want to try this for yourself, you'll enter these in your calculator and say 0.88888 and probably 9 at the end because it's just rounding off. And that'll give you a chance to try a few numbers on your own. For example, make another number, add the digits together, predict what the remainder should be, and then check it with your calculator. If the remainder you get should be 5, you'd expect the digits to be 0.555 repeated on your calculator. Now, if we were doing this together, I would have you do it in your groups. I know that you have some good working groups that you've set up for your powers of 10. I would encourage you to work together on this problem in your groups. However, I will also honor those people who want to do this individually because for whatever reason, maybe they can't get with their group and it just doesn't work for you. So ideally, do this as a group project, and then you're going to be having the option of doing it individually if you'd like. What your project is to do is to determine why this method works and to demonstrate it using sketches of your base 10 blocks. If you can do that, then you will be able to understand our explanation when we talk about and talk our way through the student discussion. When you go to present this, we'll go to discussions. We'll come down to the division by 9 section, which will be available when you see this. And you are to describe why the division by 9 method works. And just as a reminder, don't just give me an example. We already know it works. What you need to do is to be able to include any sketches or pictures necessary of the base 10 blocks to verify that you do understand why this particular method will work. And if it turns out that you can't do it yet, at least put up as much information and as far as you were able to get. The goal here is for you to have enough exposure to this problem so that you can understand a discussion when it's presented to you. So don't feel badly if you can't figure it out completely, but be sure that you at least immerse yourself into the problem enough so that you could benefit when someone else, in particular, a 5th grade young lady, presents you with her thinking in terms of how this method works.